So this is the answer to short answer question number 1. If you're saying to yourself, I can't believe she put that function on there for 3 tests in a row, well, you're absolutely right. What we're sorry about is that some people are still having trouble graphing this function. It's going to be on the next 2 tests, so I hope that you'll pay careful attention. One way to think about this is that it is taking the function e to the x, which we know. I'm just going to graph it for us here. Okay, this is what e to the x looks like. Now we want to multiply each of these values by negative 1/2. So what I'm going to do here is I'm going to plot new function, which is negative 1/2 times e to the x. Okay, so what that does is simply cut each of these in half in terms of the distance from the x-axis to the point, because you're taking each y value and multiplying it by 1/2, and then the negative sign switches it from being all positive to being negative here. Now, the next thing we want to do is add 3 to this function. So I'm going to graph one more function, which is taking g of x and then adding 3. So your function should look like something like this. And we know in particular that if I put in 0 for x, I'm going to get e to the 0, which is 1, times negative 1/2 plus 3, which would be 2.5. So this makes sense that it's going to be crossing right here at 2.5 at the point 0, 2.5. So the question 1 says, find the equation of the tangent line at x equals 0. So if we were to draw that tangent line, it looks like it would be, I don't know, something along those lines here. So we can see that the slope of that tangent line is clearly negative. So what we want to do is figure out we want to use the same function that we've used before, y minus y1 equals m times x minus x1. In this case, we're saying x1 is 0. Again, when I stick y1 in, when I put 0 in for x1, we're going to get 2.5. Now, we should get a negative value for the slope of the line, and in fact, we now know, this is something that we didn't know before, but the slope of negative 1/2 e to the x is negative 1/2 e to the x, and you don't need a 3 in here because the derivative of a constant is going to be 0. So the slope is also negative 1/2 e to the x, which would be negative 1/2, because we have e to the 0, which is 1, times negative 1/2, so that's going to be negative 1/2. So the equation for the tangent line, we just want to put those points in, and we're going to get y minus 2.5 is equal to negative 1/2 times the quantity x minus 0, or y equals negative 1/2 x. Oopsie, that should be a 0 there. That should be negative 1/2 x plus 2.5. So that's the answer for that question. Now sketch this tangent line on your graph. I already did that. You should have something that looks like that. Now use the local linearization to approximate f of point 2. So what we're saying is we know that this is the tangent here at 0. The local approximation looks like it would be an excellent guess here. So what I want to do is just put point 2 in for my x value here. So I can say number, calculate, negative 1/2 times 0.2 plus 2.5. And the answer is 2.4. That was pretty simple arithmetic, and you really don't need a calculator for it. And you can see that it would make sense to be just a little bit smaller than 2.5, so it's about 2.4.